Okay. So once I'm here, then what I'll do is I'll combine this together. Okay, can I? Let's go with E. So you can see x square cancels off. I'm left with x minus x plus 2x. This is x minus 2 plus log 2. Please bear with me. As I go through how to do, you will get a bit boring. Okay, can I? But I really want to do this slowly so that I can have all of you on my trail. Yeah. Then what do I do with the E? Log both sides. Huh? Okay, so from here, I log both sides. X minus 2. Very good. Can I? What do you see here? Cancel. X equals to 2. After you get x equals to 2, or y equals to? After that, you find the y. Sub into any of them. Very good. Okay, after that, you sub x equals to 2 into any of the equation. Let's just take 4ex squared minus x minus 2. Okay, I will be very granular here. 2 squared minus 2 is 4e power 0, which is y equals to 4. So now, ladies and gentlemen, what is point P? Point P is 2, 4. Okay? Can? Jukai? Can Jukai, if you finish, can do it easy. Can do just 2 other. Okay. Then after that, again, I look at Q. Where will Q come from? Q comes from the normal to the curve at P. What does it mean? Right? If you look at this guy and you trace him back to his ancestors, it's the normal to the curve at P. That means what do you need to find? The normal. When it comes from a normal, you have to find the normal. Oh, can I? Okay, Jaden, look again. Cuts the x-axis at point Q. That means from where? The normal to the curve at P has the x-intercept, which is Q. Can I? So it's the normal that has an x-intercept. So what do I need? I'll go back to find the normal, right? So our strategy now is to find the normal, right? Find the equation of normal to the curve at T. Okay? So to find the normal, what do we need? Guys, man up a bit, okay? Can I get used to seeing like a short answer with 7-8 marks? Okay, or 7-8 marks. So this is a question like this. You can see that there's a lot of independent training on your own. Okay, senior high is like that. Okay. Minus. Oh, thanks, dear. Okay. Okay. After that, yes, because you know that when you want to do normal, that means you will need dy dx, right? You need dy dx. You need a point, right? What is point P? Your x1, y1 is 2, 4, which is P, right? 2, 4. What's your gradient now? Just differentiate very quickly. 8x. Yes, very good. 8x minus 4. Well done, Bias. Good job. Yeah, Bias has been answering actively at the front. Why? Because you differentiate, you bring to the front. 可以吗？ Can yeah. EV is okay. EV, I feel like I haven't convinced you. So let me. Okay, y prime, you differentiate 4 up, okay, 4 go to the front. This goes to the front, is 2x minus 1 multiplied by x squared minus x minus 2. Joshua looks like he's paying attention. Okay, turn. Okay. Area of it. Okay. So this is y prime. So if I take my gradient, if I start in x equals to 2, what do I get? I will get 12. Yes, I'll get 12. Okay? I'll get 12. That means this will tell you that what is the gradient of the normal? Negative 1 over 12. Okay, so far? Okay, now? After which, take equation of normal. Y minus y1 equals to gradient x minus x1, guys. Okay, so now here, y minus y1, yes, remember is 4. It's actually 4. Your gradient is negative 1 over 12. X minus 2. Very good, Joshua. Okay, thanks for answering. So what's the equation of the normal now? Y equals to negative 1 over 12x plus 25 over 6. Stay focused, huh? Remember the big picture? What are we finding? Don't be lost. This is the equation of the normal to the curve to the curve at P2, 4. Why are we doing this? Because from this normal, he's going to give us someone. He's going to give us Q, correct? Yes, and then from here, we substitute y to be 0. Since we are talking about, okay, since Q is the x-intercept, of the normal. Okay, so yes, Q, you will have 50, 0. Okay. So, huh? Are you okay? Yeah. Okay, okay. So I found Q, I found P, P. What am I leaving now? I'm still leaving out R. Yeah. So you can see 9 marks in R. So get used to question like this. Very few. You're not asking to write a composition now, but this is really steps. Okay. Now R, the tangent is parallel to x-axis. That means what does it say about the tangent? The gradient is 0. Okay. So what do you need? You need the tangent, right? Okay. So this is what I'm thinking. Parallel to x-axis, it tells you that gradient of tangent is 0. Which means that what am I doing now? I will solve dy dx equals 0. Okay, let me just fast forward a bit. What's the, again? Now we are looking at this curve. Yes. So now what's dy dx? Minus 16 e to the power of x squared minus 2x minus log 2. If you see a question and you don't know what to do, or all else fail, just differentiate, you get some marks. If you see an integration question, you don't know what to do, just integrate, you will get some marks. Yeah, okay, can Huh? Yeah, correct. So let me get to that. Okay. So now, remember, we need to equate this to 0. So we equate to 0. We are equate to 0 to find R. Right? And you know that x squared minus 2x basically is an exponential function. Is more than 0 for all x is real. Okay? Okay, this one means for all. This one means for all. Have you all seen this before? This one means member. Okay? Can I? Since this, then therefore you have 16x minus 16 equals 0, which is x equals 1. Yes, yes. It's an inverted A. Inverted A. This means for all. For all. For all. Okay, you want to say for some, there's a, yeah. This means for all. Okay? Yeah. No, okay, you equate this to 0. You equate this to 0, right? So this will never be 0, right? So only this can be 0. So if this equals to 0, x equals to 1. Oh, yes, yes. So x equals to 1 into? What is it called? It is the y. Okay, sum x equals to 1 into y. 8ex squared minus 2x minus log 2. 1.67. 1.47152. Okay? Yeah. So you can even say that it is 1 and 4 over e. Which one? Why have to simplify the? This is fine. The question asks for exact coordinate. The question asks for exact coordinate. Let me check. I believe they didn't. They didn't. So it's okay. But if the question asks for exact coordinate, then probably this is what I need to deliver. Can? Can Timothy? Can Okay. So this is coordinate R. And are you all still following me? For those who have been following since the start of the question, well done. Good job to you. Okay, and that is all for topic 5 assignment. Okay. Once you are done, let's give you about 5 minutes to do your correction. Fast to talk. Then we'll look at AFL 2 and 4. Yeah. Huh? Yeah. Do you need help? Joshua? No problem. Your P lesson, you got learn the fireman lead? Fireman lead? No. Okay. Only, yeah. Zoe, come. Okay, let's look at AFL. 6 part 1. Point R. Point R is over here. Point R is here. Let me just put it here in front. Point R. Every point is difficult, so every point requires somebody that they came from. Okay? AFL. Okay. Let's hope to collect the AFL today. Yeah. Yes. Okay. Once you are done with the AFL, we will end the lesson. The AFL is pretty easy from what my humble understanding. Should be able to do quite fast. So So what I did is I literally find the right hand side. The right hand side, right? Supposedly is negative y ln y plus 1 over y dy dx square, right? Yeah, so you take that right hand side and work. Take left hand side and work. Okay, so my right hand side, you see, is negative 1 over 1 over, then you write dy dx. What's dy dx? 2 cos x, 2 cosine x, e to the power of 2 sine x. Okay? Is it okay? Did I get it correct? Did I differentiate correctly? How do I get the? Because this is 1 over y, right? 1 over y, am I right? This is y, right? This is 1 over y. So I'm just starting from the right hand side. Is it okay? Then negative y ln y. I'm starting with this. I'm starting with the right hand side. I'm starting with this. Why is my negative y like that? Oh, sorry. Sorry. I saw wrong. So this is my, you see, this is my negative y. This is my ln y. This is my 1 over y. And this is my dy dx square. Is that okay? Is that okay? Okay. Then I expand this. So yeah, some people can see very fast. Like I saw some of your working, you all can do it very fast. So I do it very slowly. And then I can times in. So this is negative 2 e. Wow, wait. Negative 2 sine x e to the power of 2 sine x. Look at this, so beautiful. Okay. 4 cos square x. Now here there's a square, e to the power of 4 sine square x over e to the power of 2 sine x. Just look at these two, they can cancel. Yeah, they can cancel. Oh. So cancel. You have negative 2 sine x e to the power of 2 sine x plus 4 cos square over times e to the power of 2 sine x. Okay? Yeah. I believe your d2y dx square looks like that. Am I right? And then this is equals to d2y dx square. And this is equals to left hand side. Therefore, shown. Okay, that's how you get the answer for question 2. Question 3, 4, 5, quite standard. It's the O-level kind of difficulty. It shouldn't be too challenging. Okay? All of you here, if you were put into an O-level school, for example, if you do the O-level A-math paper, I'm very confident you're going to get A1 this year. Okay, huh? But you all must remember, we are more challenging. Okay? Wait. Negative 2 sine. Wait. Okay, because what do you mean negative 2 sine x here? Okay, because I'm starting from the right hand side. Which one are you starting from? Cos x and e product. Can. Okay, need to product. Okay. So question 2 is a show. Anyone still need me to go through question 2? Is it okay? Do you need me to say some more about this? Can. No problem. Okay, so okay. Question 3. May I just remind you, first derivative test, make sure you include your number and your sign. Okay, huh? Yeah, second derivative test cannot show stationary point of inflection. Okay, remember? So 0, 0. Stationary point of inflection. This is the short summarized answer. Your other stationary point should be -3, -13.5. It is a maximum. Okay? For exam, you don't need to write down local max, local min. Maximum or minimum is enough. Can you don't need to write down local max, local min. Maximum minimum is enough. G. Someone was asking, right? There should be 0, -1 and 2 pi, -1, which are both minimum point. This is -8 This is a stationary point of inflection. You need to write down, don't just write down inflection point. Write down stationary point of inflection. Okay, first derivative test you can only use first derivative test for stationary point of inflection. Or just remember. Should be negative, okay, your first coordinate should be negative. If you sub -3, x should be -3. X should be -3. Remember, it's a plus, so it should be a plus. Right, huh? Yeah, it should be a plus. Yeah. What's it?
It's -1 and 1.
Minus 0.1 and plus 0.1. Okay. The idea is not to engulf another turning point. Then you get the wrong conclusion. Okay. Remember to sub in, find the value, inequality sign. Value, inequality sign. So you need to test the nature. Remember? Okay. You need to test the nature. So after you remember part 4 is about stationary point, test the nature. So you can find the second derivative test. You can also do the first derivative test. So first derivative test, remember, draw the 2x4 table. 2x4 table. I draw for you. Take a look. X, let's say 0, right? Find the value here. Find the value here. Okay? Okay? Yeah. Draw arrow. Yeah. Can you check again? Who do you sub into? You sub into the y, huh? No, the dydx.
Yeah.
You sub into the dydx and not the y, right? Because from the way it seems as though you are subbing to the y and not the dydx. You sub into the y, but we are supposed to sub into the dydx. Yes, that's why it's called the first. Because you are checking the gradient one. You're not checking the y value.
Because we started back and now we 0.
How do you get x plus 1 square? What do you mean? Isn't this power minus 2? How do you get this? If you take it out, what you product rule or quotient rule? Yeah, you. Brother, use quotient rule. Quotient rule.
I didn't use quotient rule. I didn't try the.
It doesn't look like quotient rule to me. This quotient rule. Look at you doing product rule. Your two. What are you doing? Wow, you point middle finger. Wow, you see if Javier 2 months only become turn bad already. Very important. Look at this toxic classmate. Okay, so yeah, after that you sub in into the dy dx. Remember? So you sub in into the dy dx. So you should, let's say, okay, it's okay. Then you write down 0.07. It's meant to be disgusting. It's fine. So then you sub in here 0.0790. 0.07901. You put more than 0. Okay? Go to the other side. So you equate this to 0 to find your answer. Okay? Can? So you equate this to 0 because that's how you find stationary point. You find stationary point, right? What is your answer looking like this? Square plus 1. Okay. Square. 这个能够割掉嘛？可以说。对，换什么换？这样换线给身躯。怎么这么奇怪的？ I take 2, x equals 0 minus 4. X equals 0 minus 4. 6x squared minus 4. X minus 4. Minus 4. 6x squared. This is how. The question I want to ask. How is it? Oh. Here you take, okay, so here got this, right? Here got this. Wouldn't this part be 4x cubed? 4x power 4x, yeah, 4x power 4 minus 4x cubed. How did your but if you factorize out, you cannot factorize out plus 1 power. Don't have x plus 1 power 2. This one have x plus 1 power 1. This is x plus 1 power 2. Their factors are different powers. You know, if you take a power 2, this one is short of 1. Yeah, that's why I answer wrong. Secant square will never be 0. Secant square will never. Ayo, why you do so much? Ayo. Same. Here you got tangent square equals negative 1 also. Yes. Okay, here, what you need sign and number and sign. Less than 0, put more than 0. Here, I need sign and number. Secant, okay, first of all, secant square, right, is a square. Fair enough. So I think the question got say something like x less than 0 or something like that. Secant square, don't forget, is secant x over 2 square. Definitely is more than 0. Yeah. Why cannot be 0? Because secant, right, is the same as 1 over, okay, secant x is the same as 1 over cosine x. You agree? Can 1 over cosine x ever be 0? Cannot. Right, because it's a fraction. If you are saying that this is equals to 0, you are saying that 1 is 0. Because a fraction, the numerator is the one that equates to 0. Or, can I? So basically, you can assume that secant square cannot be 0. You just take tangent to be 0. Okay, very good. So when I do tangent 0, I can't really like so you know, like when my trigo equation where equate to like 0, negative 1, half, those kind. Okay, half maybe still can, but 0, 1, negative 1, I can't really use BQRS. I will look at the graph. So I look at the graph. Okay, so Dorcas, you see, I look at the graph, right? Then you see tangent what? Tangent x over 2. Tangent 0.5 x. Okay. What's going on? Sorry. You will see that the zeros are at 0 and 2 pi. So actually x is between 0 and 2 pi. So using the graph is easier. Okay, using a graph. Use radian. Because this differentiation must use radian. Never use that. Okay, so how okay, when tangent x equals to 0, right? X can be 0, x can be 2 pi. So and you can see from here, I show you. Okay, so you see x can be 0, x can be 2 pi. So you see x can be 0, x can be 2 pi. These two are the answers. Stationary point. Stationary point. Actually, I'm not sure. I don't think so. Because I can't tell you right away. How about you find the second first day to check? Yeah. Okay, okay. Remember, it's a 2x4 table. 2x4 table. Oh, 2x4 table. You draw 2x3. 2x4. No. Okay, correct. Correct. Then your secant square will never be 0. Eh? How come? What's it 2x4? 2 row 4 column. 2 row 4 column. Because you need to have the indicator, ma. So why is it 2x4? Because it's like this one. You write this one first. So this one at the side. Okay. Yeah. Then negative 0.1, 0, 0.1. Okay. 2x4. 2x4 or 2x4. Okay.
This one is always positive, so I can just like leave
Yes,
it.
yes. But you need to write down, since tangent secant square is always more than 0. Yeah.
I don't get why suddenly got 1 over y.
No, because you are asked to show, ma. You are asked to show. This is what they give you, ma. Fair enough. I want to show that I this, so you start from here. That's why there's a 1 over y.
I got this one already.
No, so you need to work based on this. Use this as your starting point. You are given this. You are given this. You are given 1 over y divided by x squared. Your job is to start from here and show that you can get divided by x squared. You understand? So you start with 1 over y. Because it's not like why do I get 1 over? It's like they give you this now. Or they give you this, you start from here. So what are you doing? Question what? You get what do you get? Why make life so difficult for yourself? Differentiate. Okay. Okay, gx is tangent square half x, right? Minus 1. So you differentiate tangent square. Differentiate tangent. It's just secant square. Differentiate tangent. You look at it as tangent half x. Right, not square. You differentiate outside function to tangent half x. Differentiate the inside is half secant square half x. That's all. Why you want to go and change to sine and cosine? You're not doing proving. You do proving, you change to sine and cosine. Yes, that works. But just leave it. Yeah. Because you must know when you walk into this question, I know how to differentiate tangent. I know how to differentiate secant. All this you know, right? So if I know how to differentiate tangent, I will not change to sine. Correct? When you change to sine and cosine, when I do proving. Proving side of the tangent. Okay. Yeah. Because you will change to sine and cosine in this case, a function that can differentiate head on, you end up using quotient rule. Wow. No point, man. Okay, I guess we cannot finish the AFL. We will continue tomorrow. Practice set 1 by tomorrow, clear?
Yes.
Thank you, class.